So df by dx is
Neha,
equal to minus w.
question paper has
So
appeared.
what is this minus w represents? The
Put it in the
negative
chat
sign
box.
indicates that the shear force decreases with increasing x when distributed load acts downward. Okay, so you are going to have a negative slope.
Neha, no
You
reply.
will have a negative slope. The shear force as a negative sign indicates that shear force decreases with increasing x. Okay, when the distribution function of x.
Sumant reply.
Okay.
Question paper appeared.
Equation 1 can be
Yes, sir.
conclusion what we're supposed to arrive from these equations 1 and 2.
With a neat sketch,
Is it clear, my
explain
students?
the working of hard to dry
Load
rock
intensity
geothermal
force.
plant.
Got it? Right. So now let us move. Yeah. This one? Yeah.
This is hard to dry rock. Sumant.
Right.
Sumant.
Now let us move on to the second is in the second static equilibrium condition, which is occupied some of the moments about the point.
Sumant reply.
Okay.
Could you read this?
So now we are taking the moment about a point O over here. But here we are taking the moment about
Sumant Sagar.
point O. That is the point what I am talking
Not
about.
replying.
Okay, this is the point where you are going to consider the moment. Okay. So now what are the forces which will contribute to the moment of force about this point?
No mic. Okay.
The bending moment is acting at point.
Say, okay. No mic. I have noticed. But
Clockwise.
this hard to dry rock resource, this page has appeared on the screen. Put it in the chat box.
Why? Because it is acting at the same point where we are calculating the moment.
Question paper appeared. That's fine. But now I have opened. Say, okay. Now I have opened hard to dry rock resource course material. Separate another page. Are you seeing this hard to dry rock resource scanned copy of that notes? Put it in the chat box. Yes, sir, I can see. Okay, fine. Let us go ahead. Thank you. Thank you. Yeah, fine. Correct. Suman Sagar, thanks. Okay, what of this hard to dry rock resource? I will tell you. When the below the earth surface up to around 5 kilometers, there will be a rock also in some places. Inside that rock, there will be temperature of around 200 degrees Celsius will be there in some place, not all the place. In that place, uh, a, a small cavity is made by some means, and water is introduced in that rock. That water becomes hot, absorbing heat. Then that water is converted to steam. That steam can be taken for using for the production of energy, electrical energy, a turbine to generate like that. So that type of geothermal site comes and are called the hot dry rock resources. See the name, hot, dry, rock. Dry means no water are there earlier. Before there is no water inside the rock, and it should be a rock, not simply earth surface, and there should not be any cavities. So into that rock, the water is artificially introduced. Then that water becomes heat. That water is not into steam. That we can use it for power production. This is the principle of hot dry rock resource. Now, how this hot dry rock resource can be utilized for production of power? Let us see with sketch. Look at this. First, this portion is sedimentary and volcanic rock. Rock means impermeable. Here, temperature will be 200 degree Celsius. So they will fracture. This is a fracture. Water is introduced here. And here water is stored cavity. So this water absorbs heat. This water is converted into steam. Uh, so this is a granite. So this steam by drilling it is taken to further application. It is passed in this circuit. This is significant. Important. Hope you can understand this drawing. The bottom line circuit diagram, what path of the water and steam constitute the significant portion of this hot dry rock geothermal power plant. Weightage is given for this. More bars is for this one. Now in the upper portion I have circled and I have shown a lot of components are there. Those components are present in any type of geothermal power plant. But what does the difference makes for this hot dry rock is the bottom line what I have shown. That makes the difference. So this the during the examination evaluation time, the evaluator will look into this whether the students knows exactly what is this hot dry rack system is or not. That he will check. This makes a student to score 8 out of 8 marks or 10 out of 10 marks, 10% marks. Otherwise, if you do some mistakes in the bottom portion, top portion minor importance is right. or 8 marks, okay, 5 marks, 6 marks, or sometime between 4 and 6 months they will allot. This is how you should be careful. This is how the evaluation will be done by looking into it. However, any type of geothermal power plant, general one also it is like this only. But when you say specific, not dry rot system, you should be uh, specific with this diagram and this explanation. Once if this hot steam is taken, passing through like this, and here it is a heat exchanger, primary heat exchanger. This is so inside this heat exchanger, another fluid is flowing. So this heat is transferred to this another fluid passing through this heat exchanger, and then that is the freon it is taken. And look at this. That freon, by absorbing heat, it will be converted into vapor. That is sent to the turbine. And from the turbine, it is after losing its pressure and temperature, it comes out. And then it is sent to the regenerative heat exchanger. And then it is sent to the condenser. This is the condenser. Inside the condenser, it is condensed. And then the liquid freon is taken and it is passed through regenerative heat exchanger here once again. Here again it is cooled, but we have to um, heat this. That heat is transferred from the inside the regenerative heat exchanger, and after getting this heat, it is sent to this primary heat exchanger. From primary heat exchanger, again the cycle repeats. This cycle repeats. Okay. Now, for cooling this freon vapor, uh, cooling tower is necessary. This is the cooling tower. So from this cooling tower, the cooling water is taken here and it is passed here, it cools that one. Then it is sent to the cooling tower. From the cooling tower, again from the bottom, it is recirculated. Look at this. This constitutes three cycles, water cycles. So further, you read this course material already I have sent to you. Uh, you can read this one. This is an example case study. The technique uh, was tested at a location near Wales, Calendra, USA, where fractures were made at a depth of about 2.76 kilometers. The temperature at the location was 185 degrees Celsius. This is hard dry rack. It is used for binary fluid system. That is Freon R114 was used as working fluid for turbine as a the binary system. It need not be binary system. It can also be used for other systems also. This is one case study example. Makeup water also they will add it. No, like this. How? D square m by dx square. F is dm by dx, right? In place of F, explosion. Dm by dx. What you will going to get? Is equal to minus 1. Explosion. What is? This one. Fracture. how they will do. Look at that fracture, how they are going to do.
How to draw the shear force and bending moment. So now, once we know how to calculate the shear force and bending moment. So I think
Drilling deep into hard rocks, and then cracking it to form cavity or fractures. Uh, this can be achieved by detonating high explosive at the bottom of the well, and then nuclear explosion or hydraulic fracturing by using a dynamite, etc. They will explode that one, detonate, explosion takes place. Then on the above earth surface it will vibrate like a earthquake, and it like, which is performed by pumping of water at high pressure into the rock formation. Is commonly used in oil and gas fields to improve the flow. This is this is look at this. The recovery of heat from HDR. Hot dry rock system HDR involves forming a man-made reservoir. Man-made reservoir. This is that is this one. Man-made reservoir. Reservoir. This is man-made it is. Uh, Hope you have understood this one. Do you have any questions on this? Do you have any questions? You put it in the chat box. I will answer it. Allow put your username in the chat box. If you don't have any question, so explanation all it over. In the rest of the time, what I will do is I will keep open this sketch. You practice this sketch, and also theory portions also I will keep it open, the notes, that you read it. Okay. If after that, or if you don't want to write the sketch or anything, then you can leave. Now put your number. The class ends now. Still, those who want to practice, you practice it. I will keep it open. So those who don't want to practice, you can leave the class.
values and drawing the shear force and okay. So now let us understand what is the procedure which is involved in finding the shear force and the lab. So we are discussing only for statically determining I have already been told. So only we use the simple supported beam, overhang beam, and the uh, cantilever. Cantilever. Okay. So only for those things we will go into plot the shear
You
force.
practice this if you
So
want.
we don't want to discuss the statically distributed. Okay. So now, what is the procedure involved here? Determine the first step is determine the reaction forces and reaction moments using static equilibrium equation sum of alpha is equal to 0 and sum of the force moment about is equal to 0. That means, right? Reaction and reaction moments we need to find it out using the static equilibrium equation. So the first step is find the shear force and right? The second step is determine the shear force on all the salient points such as support, point of application of the load, and other points of load. This is another important. Once you have got the values of support reaction, right? Next thing is you need to start calculating the shear forces at all the salient points. Salient variable is very important for it. So at the first points you need to calculate the shear forces like the supports or the point of application of the load or the other point of. Once you get those values, now you are going to draw the shear force diagram using the above relationship. Above relationship is what we have got df by dx is equal to minus a. So using that relationship, we are going to draw the shear force diagram and we are going to locate the section where the shear force changes its sign. Understand? So there are some cases where the some portion of the beam the shear force value will be positive and the remaining portion it might be positive. So we have to make use of the time conventions as already we discussed.
Anybody reply? Anybody reply? This figure is appearing on the screen. Does the figure has appeared on the screen? Anybody reply as yes or no?